I work at LinkedIn as my day job, and I'm also part of Women in Big Data. I lead the networking chapter. So it's what Sunita talked about is actually very, very relevant. Actually, there are two leaders here. One is me, and another one is Eva from Netflix, who's here. We both fought over Sunita as to who's going to get her. And then he did a fair trade, took one engineer from my team who was awesome, and then I got Sunita. So we think it's a fair game. So this is what the community is about, right? And Eva is here. Say hi, Eva. And it's extremely important that we build these kind of community. It doesn't matter which company we works for, because we need to learn from each other. And that's what this platform provides. So what is Women in Big Data's mission? To champion the success of women in big data careers. It was started at Intel with a very few engineers in the beginning to figure out, hey, we don't have a community to talk to about the work, and then we need to lean on in each other, and that's how it was started. So the whole idea is to inspire, connect, grow, and elevate women in the space of big data. So it started with, as I said, 15 people in a small conference room at Intel, and today we are at 15,000 plus people across the world. We are in Australia, Europe, and a little bit in Asia, even though it's not there because it's a smaller blip, North America and Latin America. And we are growing as we speak. So you're all part of it, whether you came to know through them or not. And you can always go back and then enroll as part of Women in Big Data so that you can hear about these kind of events in advance so that you can register and take benefits out of it. So these are all there's Women in Big Data sponsor and partners. You can see LinkedIn is one of the biggest partners. The last time we had it was 2 years back, and we do have engineers who joined our team through these events. So for companies, if you're part of the company and you want to be part of it, reach out to me and I will tell you what it is to be a partner. It doesn't take much. You just have to host an event like this, and it's so much fun to do it. And so why do we do it? There are multiple reasons. This is one of the reasons. There is so much needs that are there, which are very specific to women, not just about the pay. It's about technology, feeling a kinship, having people to talk to, just like I have with Eva. So these are all the things that keep us going. How do you be part of? These are all the ways that you can find out about Women in Big Data. There is a local chapter and the Meetup page at womeninbigdata.org. Our LinkedIn group is Women in Big Data Forum. If after the Meetup, if you are registering for it, I will approve it immediately, I promise. And then there is a Twitter and then Instagram handle for you to look at. Do we have Suju? Okay. So without further ado, I will let Suju take over.
Okay, good evening, everybody. Let me also join Sujal in welcoming you all here to LinkedIn. This happens to be my very first meetup of 2020, and I am super thankful for this opportunity to spend that very first meetup with a group of people that I can totally resonate with at many different levels. Before we get started, I thought I'd give a little bit of background about myself. I started working at LinkedIn a few months ago, maybe about 5 at this point, and as a senior director in the AI organization, overseeing teams that are responsible for putting in machine learning solutions into a bunch of our enterprise products. My career path is sort of typical for people in this field. I started out with a PhD in machine learning from UT Austin. That kind of had an internship along the way, which resulted in a full-time job offer. Took that offer. This was to be an IC in a applied machine learning team at Yahoo Labs. Spent a bunch of time in the trenches figuring out how to get ML solutions working in business-facing products, how to talk to PMs, how to think of metrics which make sense across the board, and so on and so forth. Along the way, realized that I was interested in management, and here I am. Now, also along the way, happened to meet my husband at work, and now I'm a mom of 2 pretty young kids, 4 and 2. And I'd be lying to you if I said, hey, I figured out how to have the perfect work-life balance, figured out how to integrate my work life and my home life. I'm, for the most part, winging it with a ton of support from my family. Okay? So let's get started. Before we get into the main crux of the program, I wanted us to sort of be on the same page on why LinkedIn does what it does. This is the vision for our company, to provide economic opportunity to every member of the global workforce. It is not to provide opportunity for a particular demographic or a group of people living in a specific country or a specific group of professionals. It's for every person in the global workforce. It is grounded on the principle that equal talent means equal opportunity. Now, how do we operationalize that vision? We operationalize that vision by building what we call our economic graph. This is based on all of the activities that's happening on the LinkedIn platform, whether it is our members posting about their professional successes, whether it's about companies posting about the jobs that they have available. But from all of this data, we are able to have a clear insight into what are the skills that our 660 million plus members possess. What are the 30 million plus companies on our platform trying to specialize in? What sorts of jobs are they putting out there, which is at least 20 million at any given day? What sorts of skills are required for these specific jobs? What sorts of universities or other institutions offer these skills that these jobs require? Combine that with a platform which allows knowledge to flow between ML experts or any other experts for that matter, between universities and between institutions, and now you have what we call an economic graph. Now, what this allows us to answer is and understand is very interesting questions. Which particular industries are growing the fastest? Which companies are set to hire the most? What sorts of skills are required by the jobs that are forthcoming? Imagine not just being able to understand the data, but literally predict and shape the workforce that is required for tomorrow. This data, this graph is what drives our vision. Okay? And now let's look at a few instantiations of what we are able to do with this economic graph. This comes from the LinkedIn Emerging Jobs Report for 2019. So this is our prediction, or rather, I guess, our forecast of what do we think are the fastest growing job types for 2020. As an example, the field of data engineers is supposed to grow quite a bit. It ranks number 8. It has grown 30+% year over year. We are able to understand what specific skills are required for such data engineers. We are also able to say which industries are looking for these data engineers. I'm not going to steal any thunder here because I want all of you to go look at this report, but you will learn a lot by seeing, hey, what is the top 1 field and top 2 and top 3 and whatnot. And this group has to feel rather privileged for being interested in big data as much as you are. So you'll find lots of heartening facts in that particular job report. It also allows us to understand what are the effects of having a network. This is by no means a causation, but an interesting fact to know. That 70% of people who are looking for a job get hired at a company with a connection. Now, what drives these connections? What makes people connect to one another? No surprises here, but it's rather telling, right? Something that we need to think about. That people who grow up in a zip code where a median income is greater than $100,000 have 3x times more connections. People who went to top schools, the top could be defined by US News as an example, have 2x more connections. And people who worked in top companies, and when we say top, we can sort of relate that to large companies, have 2x more connections. Now think of those people who didn't have the privilege or the good fortune to have had all of these different things checked. Imagine the hit that it takes on the connections that they are going to build. Imagine what it means for them to get a referral into a company that they are interested in. This is not just something that we understand, but something we want to codify in the way this company operates. How many of you have heard of the +1 pledge that LinkedIn has run? Obviously, the people at LinkedIn have, but the +1 pledge is where we are asking every member on our platform to connect to someone you otherwise didn't know because you grew up in the same neighborhood or you went to the same company or kind of had the same sets of head starts in your life. By opening up your network to people who aren't as privileged as yourself, imagine the impact that you can have. The economic graph also then allows us to get into a fair level of detail to understand and provide insights to companies. This is a screen grab from one of our products called LinkedIn Talent Insights. And what it shows is that people who are interested in, say, the field of product development, especially in the consumer goods industry, how many members do we have in their platform? How many of them are changing their jobs? What are the different regions where these people tend to work the most of? What are the companies that are looking to hire such folks? This helps our recruiters and hiring managers to then shape their plans in terms of, hey, where do I want to target my jobs? Which geographic regions should I put my job postings up to? As a user of LinkedIn platform, I hope most of you are familiar with this view. At some point, I hope you've gone and checked out what are the jobs that are available, that things that you might be interested in, which are getting recommended for you. So this is our view as a seeker, right? And this is my particular view. Similarly, on the recruiting or the hiring side, there is access for our recruiters to search for candidates which fit their requirements and their profiles. So recruiters can search with a bunch of different filters powered by perhaps the insights that the platform provides and target very specific individuals either to send a message to or to connect to or literally start recruiting the workforce from. How this happens behind the scenes is what the crux of the rest of the talks for the evening are going to be about. You're going to hear from a host of pretty awesome speakers who are going to talk about both sides of the marketplace, as we call it. What are the machine learning algorithms that power the recommendations to the users? What are the machine learning algorithms which power the recommendations on the recruitment side of things? How are we learning from all of this data? It's obviously from all of the events that the users are generating on the platform, which kind of flow into our offline infrastructure, on which we do a bunch of analysis, including data science, where we are trying to figure out, hey, are we actually achieving the goal that we are setting out to achieve, which is to move the number of people who are getting hired through our platform. Along the way, you're also going to hear about the efforts that LinkedIn is putting in to make sure that our platform is unbiased and is fair and provides equal opportunity for equal talent. Okay. I realize I'm standing between these very inspiring talks and what I have to say next. But again, indulge me a little bit. This is my first meetup of 2020. I wanted to sort of have something as a vision for myself and for yourself that I want to share, again, which is driven by data. I will leave that quote up here, right? Many of us have heard about reasons why women are not making as much as other folks in the industry, right? Some of them exist for reasons besides ourselves, requires a larger platform than this stage to fix endemic reasons. But I feel that there are some things that we ourselves could do a little bit better when it comes to self-advocacy. And what is driving this statement? Our data shows that women want to apply for a job only when they feel they are 100% qualified for the job. Whereas the barrier for men is far less, 60%. This is a self-imposed standard, right? Nobody is saying, hey, this is where I've set the standard. This is something we set for ourselves. What is this translating into? Women apply for 16% less, 20% less jobs than men. Here's another interesting fact. Women routinely do not ask for referrals, 26% less than men. We feel, and okay, I should say I feel like somehow I have to merit that job. I shouldn't have to ask anybody for favors. This has definitely been me when I was growing up in my career. But guess what? The people who, I don't want to say competing, that you're giving a fair fight to, do not hesitate to ask for referrals. So what is holding us back? And here is the kicker. Women actually do get picked up for those jobs at a higher rate than men do. women do apply, they have a 16% more chance of being hired for the job, 18% more, even if that job is senior. Now, there is a confounding factor, maybe because we as women only apply for jobs we are highly qualified for. We are sure to nail it, maybe. But what I want to challenge each one of you as you're going forth for 2020, deciding how you want your careers to pan out, is to take a step back. I'm not going to stand here and judge and say, hey, regardless of what's going on in your personal life, lean in, take that job, stretch yourself. No, right? Each one of you are aware of what your circumstances are, what is feasible, because when you stretch yourself, something's got to give. There has to be a trade-off. I wish I could say, hey, it's a perfect world, you could do this and that, but no, right? But each one of you have some internal compass which tells you, this is how much I want to stretch myself. This is how far I can go. But within that level of awareness, make sure that you're not handicapping yourself with self-imposed higher standards than what is needed. Not asking you to lower the standards, but just don't hold yourself back because you are holding yourself to a higher and perhaps non-existent standard. If that's the one takeaway you take away from this evening, I would think my job here has been well done, but I shall pause here now and thank you all again for being here this evening, and we shall get on with our main program. And I shall ask Suman, who is going to talk about the very first piece of how we are going to recommend jobs to our users. Thank you.
That's a really hard one to follow. Okay, thanks so much, Suju. Okay, hi everybody. I'm delighted to be here with all of you today. My name is Suman Sudares, and I have been at LinkedIn for about 5 years, over 5 years in total. I'm an engineering manager, and I lead a team of amazing machine learning engineers, and we work on improving our search and recommendation systems for our job seekers. And this is very meaningful and special to me because I actually got my first job out of grad school using LinkedIn. And so I feel really fortunate to be part of the team that enables us to find ways to allow our job seekers to find their next career opportunity. So with that, I'm going to talk about JIMB. So do all of you know what JIMB stands for? Anybody? No guesses? Okay, JIMB stands for jobs you may be interested in. And this is basically our recommendations, right? And this is where you'll see JIMB. So on the mobile app, if you click on the jobs tab, you'll see a bunch of jobs recommended for you, and that's what we call JIMB. And on the web, again, you'll see a set of jobs when you go on the jobs tab. So let's explore JIMB a little bit more. So as you know, as members, we create profiles on LinkedIn, right? And some have more information than others. For example, you could have information about the current role, location, interests, preferences, skills, education, and so on and so forth. And these are member features. And on our platform, for every member, there might be hundreds of relevant jobs for that member. And again, jobs come with varying degrees of information. There could be information about the job title, company, skills, location, benefits, job description, so on and so forth. So JIMB is about solving the matching problem, right? How do you recommend a set of jobs for the member? And I'll talk about this in 2 stages. There's a retrieval stage and the ranking stage. So let's talk about retrieval. Now, given that we have millions of jobs in our index, right? If we were to match a member with every single job one by one, that would take incredibly long. And only a subset of jobs are really relevant, right? So we use the retrieval step to basically narrow it down to a subset of jobs that are relevant, retrieve those. And retrieval has to be fast so that the next step, which is ranking, can use more powerful algorithms to surface the best jobs first. And here we think about retrieval in 2 terms, like recall and precision. And recall is about focusing on retrieving all the relevant jobs. But if you cast the net too wide, you might actually pull in a lot of noise, right? So you want to also optimize for precision, which is focusing on retrieving mainly the relevant jobs. And this is a trade-off. And how is this done? So we generate a search query, and a query is basically comprised of clauses. And these are clauses matching member features to job features. So for example, you could have profile job matching clauses with user title matching the job title, and user skills matching job skills, and so on and so forth. And there are preference matching clauses. So users indicate their preferences, like the title preference or the location preference. So you'd match that with the job title and the location. And we'd combine all these clauses and then run it with the search index to retrieve the set of jobs. And we also employ machine learning models to allow us to determine which of these clauses are more important to achieve that optimal precision recall trade-off. Now let's talk about ranking. And as I mentioned before, ranking is about surfacing the best matches first, and we are optimizing for a specific goal. So when we surface recommendations, this is about allowing members to see jobs that they are likely to apply to. So that's the goal that we want to optimize. And we could have more sophisticated models for scoring, and I'll talk about GLMix in a bit. And then there'd be a final step of re-ranking and filtering based on member feedback. Now, if we surface a bunch of jobs over and over again and members don't engage with it, we might not want to surface that again. We might want to surface a different job. Or if the member gives explicit feedback and say, this job is not for me, then we'd want to filter it out too. So there would be a post-processing, ranking, and filtering step. So I'll talk about GLMix, which is basically short for Generalized Linear Mixed Models. And it's basically a mixture of linear models into an additive model. There's a population average model, and then there are entity-specific models. And we want to basically predict the response, the likelihood of a member applying to this job. And so the first component is the fixed effect model, which I mentioned is basically a model that globally determines the importance of similarity between user features and job features. Now, we can also build entity-specific models that tailor recommendations for specific users or user segments. And finally, there could be a job-specific model, especially jobs that generate lots of user responses. This captures the notion of popularity of the job or interaction with the user features. And here are some of the other things that we think about when we build recommendation systems. One is scalability. As you know, we have hundreds of millions of members and millions of jobs in the platform. So we need a robust infrastructure. And Deepthi, Zoe, and Anne will be talking a little bit more about this later. And it also needs to be up to date because members are changing profiles and we have new jobs flowing into the LinkedIn system all the time. So we'd like to surface fresh jobs too, right? And the computation has to be efficient and accurate. Now, the next component in relevance is how we represent the knowledge. So as you know, data can be varied. There could be missing data, or the same term could be called different things in different organizations, software developer, software engineer, and so on and so forth. So there's a need to basically bring all of this into a standard taxonomy. And so we leverage standardization efforts in LinkedIn to be able to do that. So then we can make the matching better. And we also apply deep learning models to semantically represent this data. And we'll talk about this a little more later. And this allows us to match better as well. And finally, we power the job seeking experience on LinkedIn using Jimby algorithms. And this is shown on the jobs tab. It's surfaced via email, on the home page, company pages, and so on. And how do we know that we're doing a good job? Like, how do we know how well our models are doing? So we measure impact based on how members engage with newer models that are developed, right? Based on the views, the applications, and also explicit member feedback that is shown in the product. And the data science team will be talking a little bit more about this later. So all that I've talked about so far is one part of the marketplace, which is job seekers looking for jobs. And then we have the other side, which is how recruiters find talent. And so the next speaker will be talking more about that. Tanvi?
Thanks, Suman. That was great information on job recommendation. And as Suman mentioned, I'm going to go a bit about how recruiters get to know the right set of candidates for their job opening. Hi all, I'm Tani Motwani. I am in LinkedIn. I'm managing a team for recruiter search and recommendations. I've been in LinkedIn for about 2-ish years now. And my journey has been with search and recommendations throughout. Before that, I was with Amazon search and recommendations. And I get asked this question a lot, that how did I come across artificial intelligence and machine learning? Back in the day, it wasn't very common, but when I was in my school, I remember I wrote pages and pages of GW basic code. I don't know if anyone can resonate to basic GW back in those days. And that was for text classification. And I just wrote heuristics and a lot of rules which were hand-tuned. And I thought we could do much better than that. Now, remember, I was still in school. So I came across this book on artificial intelligence written by Stuart Russell and Peter Norvig. And that's literally been my my move, right? My game changer, figuring out how artificial intelligence work. So that's a bit about my journey. But whatever you're doing right now, if you can figure out ways to automate it and apply machine learning, I'm sure we can do better than what we are doing right now, right? So I'll go through what my team is doing so far. Suman did talk about the member and the job side on the right side there, how members get job recommendation. What I'm going to go through is how recruiters actually find the right members for their job openings. Right? So finding talent is very, very difficult. Filling your open job requisition with the right talent is actually the #1 thing that a manager worries about. And we want to make sure we're getting the right set of talent, right? The reason it's very time consuming and tough is because recruiters actually take the pain of going through so many members we have for their open job position and actually sending an email or an in-mail. Now, how many of you know what an in-mail is, a LinkedIn in-mail? Great, I love this audience. Okay, so just to recap, an in-mail is a message that we have on LinkedIn if you want to send it to a 2nd degree or 3rd degree connection. And I personally received my job through an in-mail. A big shout out to my recruiter who's somewhere there in this room, Charles. Thank you for connecting me with LinkedIn and this great opportunity. So post that. That is the first step, right? Post that there are a set of interviews that each one of us have to take as a job seeker. And as a recruiting company, they have to go through several hours of engineering efforts to go through phone screens and on-sites and make sure we have vetted the candidate in the right way for the job position. Post that comes an offer stage. So there is friction at each point. And what my team concentrates on is reducing that friction. Now, how many of you were contacted by a recruiter for the jobs, for any jobs that you're currently working for or work for in the past? That's great. That's awesome. So the number of hands going up, we want to increase that, right? So that is the confirmed hire in our terms. That's the metric we strive for. Getting job seekers and candidates who are utterly qualified for that job role, the right opportunity is what our metric is, and that's where we want to reduce the friction and increase the efficiency. Okay, how do we do this? So just like jobs you may be interested in, we have candidates you may be interested in. A recruiter provides us with details on what is the hiring company they want to hire for, what is the job skills, what is the basic qualification, their preferred qualification, years of experience, the title of the person they want to recruit, the people they've sent emails to, the recruiter search queries in past. So a lot of data is available for our algorithms to churn, right? These all set as inputs to our algorithm. On the member side, each one of us should have a LinkedIn profile, if not. And that LinkedIn profile gives us information about the work experience, the companies you work for, the years into that company, your location, all that feeds inputs to, again, the algorithms that we have. So in terms of our algorithms, we have candidate retrieval and ranking algorithms that churn all this information to provide recommendations to the recruiter. Cool. So let's go through our actual products. So search is the product that recruiter sees on their side for getting the right set of candidates. Here you can see an instance of the search page where the recruiters typed a query of engineering managers, and we see related searches. So those are some recommendations that we have to better improve their query. And on the right side, we see some candidates. Sunita and I are there. Hopefully, we wouldn't change our jobs, but we are there in the recruiter sourcing list, right? So that is the list of candidates who are qualified for this job, for this query, right, for the recruiter. And that's from the behind the scenes, the search algorithms actually work towards getting that. Now, The next is recommendations, right? So in terms of recommendations, we want to show other candidates who would be interested in the job posting that the recruiter has. Now, this is a discovery tool, right? So we want to not show the candidates we've already shown to the recruiter. So we try to get that signal that the people that we've already shown, and how do we discover and show new people to the recruiter? So that's recommendations. Now I'll go through key challenges. Why are these algorithms so difficult to actually model, and how do we go through those challenges, right? Now, one of the key challenges for our search and recommendations is not only do the recruiters have to be interested in the candidate. So not only the candidate has to be relevant or interesting to the recruiter for their open job position, but the candidate needs to be interested in their open job position too. So if you have received an email, we also want to make sure that you've liked that email, you're interested in that email, right? Otherwise, it's a waste of time of the recruiter as well as you as a job seeker. So we want to make sure we make the system most efficient so that finally we can get people hired, right? The way we solve this. So we look at recruiter and member actions. So once our algorithms actually take into consideration the searches that the recruiters have fired and post that the emails that they've sent, and then that email is given to the candidate, and the candidate can actually say, yes, I'm interested on the email, or no, I'm not interested. We call the yes part accepts, right? So we not only optimize for emails, but we also optimize for your reply to the email, how accepting you are for the email, right? So that's the way we make sure there's two-way interactions. Moving from there. So the second challenge we have is showing few relevant candidates. Now, as Suju and Suman mentioned, we have about 600 million members on LinkedIn. For queries such as software engineer, we match 8 million members. We can't possibly show that list to a particular person to go through, right? So we want to narrow that funnel down into the most relevant set of candidates, and that can change the way people get hired, right? So making sure we do that in the right way is one of the key challenges we have. So we have a layered ranking architecture for that reason. This will go into a bit of technical details, but I love it, so I'm going to go through that. We have n number of hosts. I've shown only 3 hosts right now. Each of these hosts have indexes, and they have ML models attached to the index. So each of the index will have set of candidates that we index on, so member profiles, right? And we have several hosts because we can make this computation in parallel, right? We don't need to wait for a particular host to give the result. We can have this whole solution go in parallel, and then we have a merge and rear that actually merges the results, right? Post the merge and rear, we have re-ranker. That takes the output of the merger and re-ranks it, again with another optimization. Now, the re-ranker actually has an in-memory key value store for nearline and fresher features. So some of the features of activities are more fresh, right? And we can only store some of them. So that is the key value storage that the re-ranker talks to. And that's why the precision of the re-ranker is better than the previous layers. Post that, we just send it to the application. The first 2 layers that you've seen, the host and the merger, we call that the L1 ranker or the layer 1 ranker, right? And the re-ranker is the L2 ranker or the layer 2 ranker. Now, this is actually going down the funnel. So from L1, we decrease to a few set of members, and then from L2, we further decrease to this few set of members, and then we provide that to the recruiter. Okay, so now that we've faced 2 challenges, this is the third challenge, semantically matching millions of entities. So Suman mentioned we have several entities, and we use deep learning approaches to semantically match them. In this graph, we show you titles, such as software engineer, big data engineer in blue, and skills in red. The skills such as Spark, Hadoop. Now, as you can see, some of these titles and skills are more correlated to some other titles and skills, such as biosciences, medicine, gynecologist. Those are a little different, right? Now, what it does is we actually look at each of this, and we create a distributional vector through deep learning approaches. and we try to map those. This is simple two-dimensional mapping of those embedding vectors, and here we see that things that are closer to each other actually have closer vectors than things that are far from each other. So this helps us to really understand the semantics. Cool. The way we did this, right? Back in 2016, we had very simple linear models. Post that in 2017, we had decision trees, which is how we trained models. We did extensive feature engineering between 2017 and 18. And in 2018, we launched our deep learning model, right? And that's where we can actually use the goodness of embeddings and semantic analysis with the deep learning models. In 2019, now we are trying to add more embeddings to our deep learning models. So we are completely moved to this framework called TensorFlow that helps us train deep learning models. Cool. So we faced all three challenges. We found solutions to that, but it's only day one. There is so much more we can do. A lot more work on semantic embeddings that I spoke about. There's a hell of a lot of work on personalization that we can do better for the recruiters, and we have been working towards that. We have our objective function of confirmed hires, you guys that get hired, so we can do better with that. And there is AI in different components of our products. We want to make sure AI goes through a lot of these automations of our products, right? With that, Jenelle will actually speak about how do we make sure this candidate retrieval algorithm that I just spoke about is fair, right? Just making sure each part of the population gets treated in a fair way is what she'll go through with you guys. Thank you.
Hi, thanks for the great talk, Tanvi. So I'm Jenelle Bray. I'm a engineering manager in Trust AI org. And so I've been at LinkedIn for over 6 years now. Before that, I used data to understand how proteins bind to molecules, and now I use data to make sure that members have trusted experiences on LinkedIn. Oh, I see. Okay, so you've just seen two great talks about how powerful AI is at matching members with jobs and recruiters with talent. But with great power in AI comes great responsibility. And LinkedIn is a members first company, so we take the responsibility of fairness in AI seriously. So unfortunately, there's just inherent biases in society, and those often show up in training data when building models. There have been several examples of biased AI in the news, and a few years ago there was one example that had very unfortunate search results when you searched unprofessional hair for work versus professional hair for work. But these come up all the time in every company, but at LinkedIn, we want to make sure that AI is being used to ensure economic opportunity for every member of the global workforce. And in order to do that, we want to proactively counter biases in our models. So in recruiter search, which is the model that Tanvi just spoke about, our goal is to have the top search results be representative of the broader qualified candidate set. So what does that mean? So if you search something like data scientists in the San Francisco Bay Area, then you take all the members who qualify for that search, maybe it's 55% women. So then we want to make sure that in the top results, so the top page of the results, top 1, top 2, top 5, et cetera, it's also roughly 55% women. So we call that fairness aware or representative ranking. And so we do re-rank the candidates that come out of the recruiter search AI model. And I want to go over at a high level how this re-ranking happens. So, and you can do this with any attribute, but I'm going to be talking about inferred gender here. So you would partition the set of potential candidates into different buckets. And then once those are partitioned, you rank the candidates in each bucket according to the scores assigned by the original machine learned model from recruiter search. And then we want to merge these buckets back in, but we also want to, at the same time as merging, obey the representation constraints based on the proportions computed overall. So in our example, it would be 55% women for data scientists in the Bay Area. And so we're saying in the top 1, top 2, et cetera, in the top search results, it should be basically the same distribution on on gender in this case as the overall distribution. So there are some advantages to this approach. First, it's agnostic to the specifics of the model that you're re-ranking. And so as Tanvi was describing, recruiter search went from linear to tree-based to deep learning. But because this is a post-processing step, this is scalable to any different model. And then also because it's a post-processing step, we don't have to change the infrastructure of the original ranking model. It's just adding a new component to that model. And finally, and most importantly, it ensures that the search results presented to the users of LinkedIn Recruiter are representative of our underlying talent pool. So this has been ramped to all recruiter users. And when we did an A/B test, so half of the searches were re-ranked according to the fairness re-ranking, and then half of them weren't. We actually had no significant difference in the business metrics. So those metrics like in-mails sent, in-mails replied to, et cetera. So actually in this case, equality of opportunity came without any business costs. So this is just one example of our work on fairness. We're asking a lot of questions about fairness, and we certainly don't have all the answers. Fairness is an evolving area, and different people have different ideas about fairness and even the definition of fairness. But as a members first company, we're committed to asking these questions and working in this area. And so now that you've heard about AI and how it helps members find jobs and recruiters find talent, I'm going to introduce you to the people to talk about the infrastructure to serve this AI at scale. So Deepthi is going to come up and talk about infrastructure online.
All right, thank you, Jenelle, for that fantastic talk on fairness, and thank you everyone for joining us today. My name is Deepthi. I'm a senior engineer in the data infrastructure team. And I want to talk to you about how our infrastructure powers jobs you might be interested in, or JIMBY as we call it. Our primary goal of the infrastructure team is to ensure that applications like JIMBY are able to focus on their business logic and not have to worry about managing their data. But before we talk about how infrastructure powers these applications, we want to give you a sense of our scale. Instead of me just giving out those numbers, we thought it'd be fun to have you guess some of these numbers. And that brings us to our fun quiz.
All right. So myself and Irene will coordinate this with Deepthi. So some ground rules. No LinkedIn employees can answer these questions, so please stay out. We will probably have 3 or 4 guesses going around. So if you do have a guess that you want to share, please raise your hand. We'll come around with mics so you can speak into it. And the closest one, whoever gets it right, of course, gets a cool prize. We have some very interesting books to give away. So those are the rules. Are we good to go? All right, first question.
How many members does LinkedIn have globally?
600 million.
Yeah, that was the easy one. If you paid any.
But let's make it a bit more challenging. Who can get closer to the actual number? Okay. 60 million. All right. There you go.
How many open job listings are on LinkedIn?
$20 million per day.
Cool. All right, that was bingo. That was right on spot. All right. I think we'll have to find more gifts giving away. So, all right.
How many open source projects has how many projects has LinkedIn open sourced? Contribute to a lot. So this is projects that started off at LinkedIn.
I think I can go there and right.
About 40.
Let's go here.
100?
Okay. Any other guesses?
20.
All right. 20, 40,
1,000.
That's way too high. So let's do one last.
67.
All right. Okay. This is truly the last. I'll pick the one that was
75.
75. No. Okay. All right.
200.
Cool. So that's actually a split, right? Because we have a number that's both ways over. But I'll go with the first one that came closest. So the right answer is 150 and counting. And I think somebody here said 100. All right. Here you go.
Right. How many nodes are in our largest Hadoop cluster? They're pretty large clusters.
7,000.
7,000. Okay.
Went over here?
1,200.
Uh, 850.
No. Okay. One. Let's.
10,000.
Okay. All right. So I think we'll stop. The first answer actually came very close. We are between 5,000 and 6,000, and so the person who said 7,000 here, I think, was close. And we encountered a lot of interesting scaling challenges with running a cluster with so many nodes. I don't know how many of you are in the Hadoop ecosystem, but name node is a scaling challenge that we constantly face. And a lot of my team members are here, so you can talk to them about what we've done to actually manage a cluster that big. Cool. Next one.
How many Kafka events does our cluster handle per day, overall, company-wide?
1.2 million.
No.
That was so specific, though.
1 terabyte.
Number of events, so it's a count. Okay. All right. So to be fair to everyone, Suja just shouted out it starts with a T. Okay. So all right. So someone here.
7 trillion.
That's good. All right.
How many bytes?
So this is our last question. So
how many bytes do we process offline per day?
And Suja, no giving away the where's Suja? No.
2 peta.
That's right. That's bingo. So awesome. All right. Thank you so much, Irene, for helping out with this. And I would really like to call out that Irene found her way through LinkedIn through one of the Women in Big Data events. So yay for events like this. Cool. All right. Off to you, Deepthi.
All right. Thank you so much for your participation. And I hope it underscores the importance of good infrastructure. So the infrastructure teams help manage the 4 primary stages of a data lifecycle. Large number of events get generated by user activities all across the globe. Users updating their profiles, new members joining in, jobs getting posted. All of this data gets persisted into multiple data stores and message queues. Data from all these heterogeneous sources then get transported to various parts of the system where they get ingested by multiple applications to be processed. Our processing is done both offline in time-bounded batches as well as nearline as continuous event streams. And all of the processed data is then made available for easy access for the rest of the system so that it can feed back into the user interaction experience. Let's look into some of the core online and nearline services that Chimbi uses through all of these 4 cycles. LinkedIn uses multiple data stores because one store doesn't fit all of our needs. For example, our jobs data gets stored in Oracle. LinkedIn uses Oracle for all of our relational data, and it's also the legacy database that we started off with. As LinkedIn evolved over the years, so did our data needs. And much of our data did not have the need for a full functionality of a relational database, and we couldn't justify the cost associated with using one. For example, as Suman mentioned, member profile data doesn't have a fixed schema. And that led to the development of Espresso. Espresso is our document store, and it's designed to scale horizontally. It is our source of truth database for all member data, and with 660 million members and counting, it's growing at a large scale. A lot of user events also get into message queues like Kafka. Data from all these heterogeneous sources need to be consumed by multiple applications. All of these applications accessing the online database to query for changes isn't really going to scale. So we need an efficient ingestion service, and that's Brooklyn. Brooklyn provides change data capture, wherein streams writes to databases as a continuous stream of events into messaging systems like Kafka. It also provides bridging, where it can bridge different types of messaging systems like Kafka to, say, Azure Event Hub or AWS Kinesis. All of these events, including the change data capture events, need to be distributed to various parts of the system reliably, and we use Apache Kafka for that. Kafka is our de facto message transport layer and deals with all data that is in motion. Kafka is used in multiple ways. It's used as a message queue between applications. It is used for replication of our databases across data centers. And it's also used as an efficient ingestion service. With its publish subscribe semantics, it can easily scale to thousands of consumers with very little overhead. All of this data that is ingested needs to be processed to derive complex insights. Most of this processing happens offline in batches of, say, days or hours, but a lot of processing also happens online as continuous stream of events as they flow in. So, and these processing applications are of varying degrees of complexity. But we need a standard way to write these applications so that applications don't have to worry about saving their checkpoints or saving their state or distributing their processing. Stream processing presents some unique challenges, and Apache Samza is LinkedIn's answer to those challenges. Samza provides a pluggable I/O model, so your application looks the same no matter where the input comes from and where the output is written to. It also has a rich API offering, so applications could be written in Python, Java, or even SQL. And it also has a flexible deployment model, allowing for as little or as much of resource management as required. For example, Chimbi utilizes Samza to standardize member data, to update search indexes, and to compute job embeddings. Now, all of this processed data from our offline processing and stream processing needs to be made available back to the online applications so that they can improve the user experience. Some of our processed data goes back into messaging queues and databases, and some of them make their way back into more specialized derived databases like our graph database, which is powering the economic graph. Chimbi makes use of two of our more popular derived data stores, Venice and Pinot. Venice is our distributed key value store, and Pinot our distributed OLAP data store. Another important derived data access layer is Glean. Glean is our search as a service infrastructure, and it covers multitude of search verticals like people search, job search, as well as our internal index searches. It uses Lucene for indexing and gives the framework to build base indexes offline, and also has a stream ingestion pipeline to apply live updates. Base indexes are pretty huge and take really long to build. So application of these live indexes on top of base index really improves the freshness of our results. When new jobs get posted, get indexed within a matter of minutes as opposed to days. And finally, all of our data from our stream processing as well as from our online stores are made available offline for more complex processing offline. So to talk about offline, I'd like to invite Zoe.
Hi everyone, I'm Zoe from LinkedIn Spark team. And thank you, Deepthi, for introducing the online part of the data infrastructure at LinkedIn. And now I will go through the offline infrastructure that powers job recommendation, fairness, and many other products at LinkedIn. And then I will do a case study on a fairness use case on top of Spark. And a little bit about myself and how did I get my LinkedIn job. Back in 2016, I went to Grace Hopper Conference for the first time, and I got my LinkedIn internship on Spark team there. And last year, I went back to Grace Hopper Conference again and gave a talk there on how to scale Spark at LinkedIn. All of this means a lot to me, and I hope all of us can come together like what we're doing right here, right now, to make this women in tech community better and better. Oh, yes, you remember that. Thanks, Suja. Yeah, back to the topic, the offline infrastructure. Here is where the offline infrastructure sits in our data stack. It takes the data from online events and provides the infra support to the data science and machine learning related work. And now I'm gonna give you an overview of the the offline infrastructure at LinkedIn. So in the offline world, everything starts with source data. So we have all the user data, events, the page view events, every click you've made on LinkedIn, everything that got through our online system, such as Kafka, Espresso, Venus, Oracle database, and various third-party resources, such as S3 and Salesforce data. All of this come from the online world and got ingested to our offline world by our ingestion tool called Goblin. It's an open source project that developed in-house at LinkedIn. And once Goblin takes in all the data from the online world, it will lend the data to HDFS, the Hadoop file system, our offline storage system. And then the data is available to the users. And when I say users, it means LinkedIn engineers and data analysts. The data is made available to users through this beautiful logical abstraction layer called DALI. And in terms of the actual computing work, we have a few multi-thousand nodes Yarn clusters that are available to do the computation. And we have various computing engines. Back in the old days, we were widely using Pig and Hive. Later, we have Spark, TensorFlow, and Presto. All of them are popular open source projects, and LinkedIn runs them at a very large scale. Right now, Spark dominates the offline computation at LinkedIn, and we'll do a case study on Spark later. Users run their workflows on top of these compute engines, and all of these workflows are orchestrated by our workflow orchestration tool called Azkaban. It's another of our open source projects. And users run workflows there to achieve their goals, such as A/B testing, machine learning model training, data analytics, and various reporting purposes. Cool, now you have some basic understanding of our offline infrastructure. Let's do a case study on the join algorithm on our fairness case on Spark. Let's do a quick survey first. How many of you have heard about Spark before? Cool, that's almost every one of you. How many of you have actually used Spark before? Oh, that's still a lot for you, cool. So as you all know, Spark is a very popular open source distributed compute engines, and LinkedIn runs it at a very large scale. It powers lots of products at LinkedIn, such as the job recommendation and fairness we just mentioned. However, Even though Spark is very powerful and we run it at this large scale, we still face lots of challenges when running Spark. And let's take the fairness case, for example. Here we want to join 3 tables together and get the scorables for the records in the final table for future use. In this case, the 3 tables are 2 entity tables and 1 pair table. In the fairness case, both the entity tables are member tables, and the pair table is the connection table. Here we want to first join the member table with the connection table and get the intermediate join table. And then we will join the intermediate join table with the other member table and get the final join table. And then we will score every single record in this final join table in a pre-trained machine learning model. However, do you notice the problem here? I guess you already know how many members that LinkedIn have. That's more than 600 million members, and that's twice as much as the US population. So you know the member table is huge here. And we're joining 3 huge tables here together, which requires lots of computation resources. And even though we put this much computation resources there, the job still couldn't finish. And the problem here is the intermediate join data got exploded. And the data shape is like a diamond. After each join step, the data exploded. And after the final scoring step, the data shrinked. That means we don't really need to materialize all the data, and because we only need to keep the scorables for future use. And the question here is, can we perform this 3-way join and scoring in a single phase? And the answer is yes. Spark team has come up with this innovative 2D partition join algorithm to make fairness possible. Let me quickly describe the algorithm. So here, both the left table and the right table are the member table, and the pair table is the connection table. We first want to partition all the 3 tables. We'll partition the left table into M partitions, and the right table into M partitions, and the pair table into M times M partitions. So this way, for each partition in the pair table, we will have a corresponding partition in the left table and a corresponding partition in the right table. And for each partition in the pair table, we will join it first with the left partition, the corresponding left partition, and then join it with the corresponding right partition. And then for each joined record, we simply apply the scoring function right away and output the scorables. This way, we don't need to explode the intermediate data. And this approach makes the mission possible and efficient. And that's it for the offline infrastructure. And I'll hand over to Anne to talk about the ML infra, which is on top of the online and offline infrastructure. Thank you.
Thank you for Zoe and Deepthi talking about the online and offline infrastructure. My name is Anne. I've been with LinkedIn for 3 years. So I still remember that 3 years ago, I got an email from the recruiter and gave me the chance to take the interview. So later, when I have this chance to work with recruiter search jobs you may be interested in those teams, I got motivated to help them to build better product that can benefit more members and more people. So today I'm going to talk about the machine learning infrastructure. My team is to build the infrastructure to power all the machine learning use cases. As Zoe mentioned, our infrastructure is built on top of online and offline infrastructure for scalability. So this is a normal life cycle of a machine learning project. Normally, for a new use case, we start with problem definition. So we define what problems we want to solve, and we also define the relevant metrics that we want to later use to evaluate how good we are solving the problem. And then comes to the next phase, which is the data collection and labeling. For this phase, we collect a lot of data and we label them. That's for the preparation for the next phase, which is the model training and evaluation. In this phase, usually we try with various of model architecture and we evaluate based on the trend model and trend data to get the metrics out. And from all the metrics we got, we pick the best model we have, and it comes to the next phase, which is the model deployment and monitoring. For this phase, usually we do A/B testing online, and we use the metrics that we defined previously to evaluate how good we are solving the problem, and we got the real online data to evaluate on that. So our team is to focus on that problem cycle and provide the info support for that. So for the first one, I want to talk about some challenges and how we solve that for the model training and evaluation case. Because we are working with all the LinkedIn machine learning use cases, for example, job you may be interested in and recruiter search. For each use case, they have their own uniqueness and they have their own requirements. So the infrastructure we deliver needs to be very powerful and flexible. So in order to do that, we introduce this concept of steps. Basically, we categorize the whole training process into multiple steps, and each step is with its well-defined and unique functionality. For example, I list some steps here for this feature provider. The functionality of that is to load the data and provide the capability of doing join on these big tables. And we have other steps. When we moved from, we have a lot of different model architecture. When we move from traditional machine learning to deep neural network, we want to make the whole move seamless and easier. The quicker we deliver the info, the sooner we can better experiment those fantastic ideas. That's why we introduced this concept of flavors. You can treat steps as abstraction of API that defines the input and the output. And then you can treat flavors as different implementation of the step. For example, for this trainer, we have the GLMix trainer. It's used for training the GLMix model. And we also have this TensorFlow trainer that can train on the TensorFlow. So then our user here, I mean, our LinkedIn employees, normally they are data scientists or machine learning engineers. They can use our steps, our flavored implementation to build their own recipe. That's the concept of pipeline. Basically, it's a blueprint of your training process. So as I mentioned, we have different flavors. Because of this GLMix trainer, we saw a lot of lift in our online experiment. And we also open source this GLMix algorithm. You can see we saw the GLMix compared with the linear regression. We saw 20 to 40% lift in the job application case. We also saw constant 10% to 20% lift in job detail views. Basically, with this algorithm, we recommend more relevant jobs to our members. And also we have this TensorFlow trainer. And basically we build the infrastructure so that the modelers can focus on their model building and our infrastructure can take care of the remaining. For example, our infrastructure is capable of detecting what's your running environment. If you are running locally or if you are running on a distributed system. Based on the detection, we can make the run more efficient. To deal with the scalability issue, our TensorFlow trainer is built on top of Spark and Tani. Tani is another open source project by LinkedIn. It stands for TensorFlow on Yarn. So now I want to introduce you more products that we deliver to power not just the offline, but also online. One of them is Frame. Frame is our feature accessor manager tool. It enables access by naming, and you can treat that as a virtual feature store. What makes it powerful is it can use both online, offline, and you can also use that in nearline. So for offline and online, it takes care of different challenges. For offline, it takes care of join and compute logic in training. For online, it takes care of fetch and compute logic. Basically, for online, the efficiency is very important. We want to have shorter SLA so that we can serve the most relevant results to our end user quicker. So this frame is built with in-memory cache so that it can provide some efficiency for online inference. And because of its capability of accessing by name, it also enlarges our feature sharing at LinkedIn. For example, if one define a feature called A, then multiple applications can access that feature by the name and use that feature in their models. Another thing is about our inference engine. For our model, we also have a lot of flavors. The most popular one is called Quasar. Quasar is our inference engine. Basically, it's an efficient engine that can do feature transformation, scoring, and ranking. So when we start work with TensorFlow, we build this model serving library. Basically, the model serving library leverages the TensorFlow serving library, which is an open source C++ high performance library for serving TensorFlow scoring. So we use Quasar as an abstraction that hides the interaction between Quasar and this library. And this library manages the process for doing the TensorFlow scoring online. When you have the recipe, the next step is to run with your recipe. Usually for the offline model training, you will have a lot of iterations. You can run one pipeline multiple times with different variants. So a big challenge there is about the trackable, because you run multiple times. You want to record all the metadata for those multiple runs, and then you can review it later. So for the infrastructure we deliver, we have this capability that every run we emit some metadata, and we have this general metadata store, which basically consumes the Kafka event and store the metadata in the MySQL database. And later, after some time, our user can go to our UI and check what's the output of my run and what's the output of my previous runs. This powerful capability actually powers their use case of debugging some problematic runs. Also, it's very critical for them to reproduce the successful run. So next, let's welcome Fiona and Xiaonan to talk about how to measure the impact with data scientists.
Thank you, Anne, for the great talk. Hello, everyone. My name is Fiona. I'm a data scientist at LinkedIn Careers team. So at this point, I feel that my story is already a little bit cliche. Similar to a lot of previous speakers, I received an email 3 years ago, and I got a job at LinkedIn through LinkedIn's help. Ever since, I have been helping other job seekers find their next opportunity.
Hi, I'm Xiaonan. I'm very happy to be here. I've been at LinkedIn for 2 years. So I got my LinkedIn job through an awesome LinkedIn feature called Ask Referral. Since then, I started to building products that help more job seekers to find their dream job as soon as possible.
Okay, great. So our colleagues have been telling you a lot of great things that we have been doing with AI and infra. Now, the big question is, how do we know that those efforts are working? How do we make a decision on which effort do we want to adopt? And how do we measure impacts of these efforts, right? So here is where data science comes in to help. In the grand scheme of things, we're the consumer of all the tracking events, member data, and job data on LinkedIn platform. We apply our metrics on top of those useful information and bring back data-driven information to our AI and product partners. So at a very high level, data science drives value at LinkedIn from 3 things, right? First of all, we empower our partners to access data and insights whenever they need them. Second of all, we optimize business and product performance, leveraging the insights we bring from data. Lastly, we also innovate the way on how insights can help business grow through data. So to give you some concrete example, we actually cover product data science from end to end. Starting from the very beginning, we start by asking the right question. So basically, how do we define success, and what are the metrics that we want to measure for all the projects we launch at LinkedIn, right? Once we have those big ideas in mind, the next thing we do is to work together with our awesome engineering team to specify the tracking needs that we will require to make those metrics available. For example, what are the user behaviors that we want to track on our LinkedIn platform? What are the member data or job data that we want to store? Third of all, once we have all the tracking ready, we start building up the metrics as well as dashboards so that our business partners can keep track of their business performance on a regular basis. So there's one great thing about LinkedIn platform. We have something called Unified Metrics Platform. What this means is, as long as we define the metric logic on this platform, we can use them directly in A/B testing, analysis, or dashboard building. So now we have done all the hard work. It's the time to have some fun, right? The very last step will generate insights through A/B testing, modeling, and deep dive analysis. Now, Xiaonan and I are going to give you some real-life examples of how this life cycle works. So starting from the very beginning again, take Jinbi's example. We start by defining the metrics we want to measure. Taking a step back, all the job-seeking products at LinkedIn, we focus on getting people hired. So what we want to measure as the first step is the entire job-seeking funnel. We start from the very beginning. Imagine you land on LinkedIn Jobs Home. You see a bunch of job recommendations, the jobs you might be interested in. Once you see that, you actually already create job impressions, right? If you feel that those jobs look relevant to you, you might decide to click into it. Once you land on the job detail page, you create job views. If you feel that you might be a good match for those jobs, you may click into it to apply, right? At that point, you create job applies. Let's say if the recruiter feels the same way as you do, they reply back to you, they give you a response. Now it becomes a two-way interest between you and the recruiter. It becomes a jobs in action, and we call that as an employer response. At the very step, what we care most definitely is the hires. We care about the job changers that got their jobs through LinkedIn's help, because this is how we measure ourselves. This is the customer value that we bring to both the companies and the job seekers. Now, the question becomes, for some products like Jinbi, right? Are those metrics enough to measure Jinbi performance? Probably not. Because what we also care about is how do members think of Jinbi, this product itself, right? Through previous user surveys, we realized that members care a lot about job freshness and job liquidity in those recommendations. I'll tell you a little bit more by what I mean by freshness and liquidity. Let's say if you go to LinkedIn platform and all the jobs that you see are from, say, like 2 months ago, do you feel that this platform is great? Right? Or every time you go to LinkedIn platform, you don't see any jobs recommended for you, or you only see like 1 or 2. Do you feel that this is the right place for you to find a job? Not so much, right? So to understand the member needs from those fronts, what we measure is percentage of jobs posted X days ago distribution, as well as percentage of results with no jobs, this distribution. By looking at those two things, we'll understand a little bit better the freshness and the liquidity that we provide to members through our recommendation. Now, I have another question for you. Imagine all the jobs you see on LinkedIn, they're fresh, and we always see a bunch of jobs on LinkedIn. Does it mean that our recommendation is good enough? Not necessary, right? So another thing that we do is, from previous presentation, you probably see this feature in job recommendation. So we ask you directly, do those jobs feel good to you? You can give us a thumbs up if you feel right about the jobs we recommend to you, or thumbs down if you don't like them so much. By looking at percentage of ratings with thumbs up, we get a better understanding of how members perceive the job recommendations we give them. I know that I have thrown a lot of metrics at you. So does it mean that every time we ramp something up, we have to see green signs from all those metrics? Not necessary. So every time we make a ramp decision, we always anchor back on 3 different things. First of all, what's our true north? In this case, our true north is to get people hired. So we look at confirm hires as our end goal. And the second of all, what's the specific purpose of a particular experiment? Sometimes we care more about member engagement. Sometimes we care more about the precision. In those cases, as long as we can get alignment with all the stakeholders on the things that we would need to sacrifice for, we have the green light for moving forward. And lastly, like previous presenters mentioned, what we also care about are some big missions, right? For example, bring equality to the entire workplace. As long as we hit those three things, we're ready to ramp things up. Now, Xiaonan is going to give you some further introduction on how we do experimentations.
Cool. So Fiona introduced some of the key success metrics to measure the job recommendation success. Now it's time for us to actually leverage those metrics to do data-driven decisions through our A/B testing platform. But before I dive into a real detailed example, I'd like to first introduce a little bit why we care a lot about A/B testing at LinkedIn. So basically, we'll follow three key philosophies. So first, we are a member-first company. We heavily leverage A/B testing to make sure we only launch features that are beneficial to our members. We further do segmentation, such as students, active job seekers, to personalize member-seeking experiences to make sure the product fits members' interests and needs. The second philosophy we follow is a business strategy. As LinkedIn grows, we heavily, increasingly rely on good strategies to bring our product to the next level. A/B testing offers the most scientific way to measure business impact. And third, we also leverage A/B testing to translate our effort into real business impact. So the team has a very clear and objective success criteria, which will give the team more focus and control and feel more fulfilled by doing so at LinkedIn. Now, after we understand the reason behind and the key philosophies of A/B testing at LinkedIn, let's dive into a real A/B testing example. So quick show of hands, how many of you ever received LinkedIn job recommendation email or notifications in the past? Show me your hands. Wow, a lot. Cool, awesome. So many of you are very familiar with the product. Let's take this example. So as LinkedIn is a member-first company, we want to optimize member experiences. So we tested every change through our A/B testing platform. We tested like email subject line change to the backend algorithm upgrade. So here on the screen, you can closely see, we closely monitor the key successful metrics through our A/B testing platform. We monitor like email click-through rate, we monitor job liquidity, job freshness, et cetera, on our A/B testing platform. The platform at LinkedIn is very powerful and yet easy to use. So you can directly get the metrics impact with clear p-value to tell you the statistical level, and error margin comes for free. Furthermore, you can also customize the report. You can do segmentation such as platform breakdown, mobile versus desktop, to actually deeply understand member user experiences across platforms. You can also customize the analysis time period just simply by clicking in the UI. We also understand there are chances and cases that A/B testing is not the option. For example, as LinkedIn directly communicate to our members more often through our job recommendation emails or notifications, we want to make sure we only recommend the jobs that are most relevant to you and also holding the high quality bar. So in these cases, in order to answer this question, A/B testing is not the option because we don't want to hurt the member job seeking experiences by removing those key job attributes. So how can we actually understand the impact? So we want to understand what is the impact for each key job attributes with respect to member job engagement. We conduct causal analysis first by collecting data from both member side and job side. From member side, we collect job engagement data such as job view, job applies. From job side, we're collecting data such as job title, industry, function, etc. We first, through the correlation analysis, we understand member action, job engagement with respect to each key job attributes. Then we do causal analysis to review the impact. With proper sizing, we prioritize features with largest impact to implement in our product. So step by step, with cross-team collaborations, we optimized our member job seeking experiences. Remember, LinkedIn is always a member-first company. So we are in it together to bring an equal opportunity for every member on the global workforce. Now I'm going to welcome Sunisa back on stage for the closing remark.
Thanks so much, Shannon and Fiona, and all our amazing speakers for great talks. Hope you all found it very insightful as well. So just dovetailing on what Shannon mentioned, data and metrics are great, but I think it's very much important that all of us actually make sense of that data, bring our values and sensibilities into it to make fairness in job search and a bunch of different things that we do with artificial intelligence possible. So I think we are very close on that path to fulfill that vision, to provide economic opportunity for all in our global workforce. The second thing I want to sort of underscore here is that I was a volunteer at the Women in Big Data event 2 years back, and it's a huge sort of reflection on how far we've come in the industry in terms of the infrastructure and all the changes that happen. So I think it goes without saying that change is the only constant, and events like this help us all connect, learn, and be inspired and contribute back to make the world a better place. All right, with that, I'll invite our speakers back on stage for Q&A. There'll be a mic stand there, so please go ahead with that.